Okay, so we are going to do this review, and then we are going to jump into difference of squares, and then this it's kind of like a trick. It's kind of, but it will help with big numbers when you're multiplying, when you're doing squares of bigger numbers. It's a trick, and it only works for certain ones, but it's an interesting thing, and it kind of leads into difference. It kind of leads itself to difference of squares as well. So for this one, so we're going to factor this. So this is just review. So how do we factor this?
Well, 8 yeah. 8 can be divided into 4 2s.
Okay, but there's no other, so we're going to do this as a polynomial, so we're going to factor this. So what we want is we want our factors to look like this in the parentheses, remember? Yep. So when we do that, I'm just going to erase that. We are going to use, since the first polynomial, since our first term has a coefficient of 1, we just have to look at the third term, which is 7, and figure out what factors of 7 we can use to create 8. Because remember, the AC method wants us to use the factors of 7. Well, AC, which A is 1. So to find 2 factors of 7 that multiply together to get AC, and then so it'd be 7, and then those 2 factors to add together to get B, which is 8.
Mm-hmm. Yeah, I remember this now.
Okay, so what can we use from 7? So we have our 2 factors that equal AC, which is 7, and those same 2 factors are going to add together to give us 8.
It's 7 and 1.
It is 7 and 1. So 7 and 1 fit both of those. So we don't have to group these. We don't have to split our B because there is not a number right here in front of this G squared. All we have to do is use those 2 factors in our parentheses. So G plus 7 and then G plus 1. And those are our 2 factors. And the way we find out if that is correct, if we are correct, is we just multiply it out. So we would multiply it out by doing, we could do G plus 7 times G plus 1. 1 times 7 is 7. 1 times G is G. And then G times 7 is 7G. Why is this not working? There we go. Sorry, my mouse was not working. And then G times G is G squared. And then when we add all those together, we get G squared plus 8G that is not an 8G plus 8. It will not do it right here for some reason. My mouse does not want to work. 8G plus 7. So we got our original back.
Mm-hmm.
Okay. So let's go on. This one has a coefficient in front of the first term. So we need to figure out the factors for this one. So we need 2 factors that equal AC, which A is 3, C is 2, so A times C, so that would be 6. And those same 2 factors are going to add up to give us our B, which is 5.
Four and no, 3 and 2.
3 and 2. Okay. So we have 3, we have 2, 3 times 2 is 6. 3 plus 2 is 5. Okay, so this is the one where we split the b because there's a coefficient in front of our first term. So we rewrite it as 3u squared plus 3u plus 2u plus 2. Okay, now what do? So I split the b into 3u and 2u.
Now we make our parentheses.
Yep, so now we group with parentheses. So we group our 3u squared plus 3u and then our 2u plus 2.
Okay, and now we can see what we can draw from the first parentheses set.
Yep, so see what we can factor out. So what do they have in common here?
A u,
Okay, they do have a u. What else do they have? There's one more thing.
a 3.
Yes, so we can take out a 3u. And when we take that out, we're really dividing. So 3u squared divided by 3u is what's left over. In this first term, if we take out a 3u from 3u squared, what is left over?
Just 3u and 3.
So if we have 3u squared right here, and we're taking out the 3, and we're taking out one of the u's, what do we have left? We just have one u left. Yeah. All right. So what about the second one? If I take out a 3u from 3u, what do I have left?
Nothing.
1. 3u divided by 3u is 1. So if I write it like a fraction, when we have a fraction in the same, it's the same on top, the numerator as the denominator, that fraction's equal to 1. So that's why we get a 1 there. Okay, so what can we take out, or what is a factor, a common factor for the second grouping here?
There's 2. They had that in common.
So they have it. Yep. And can we take anything else out?
No.
No, because there's no u on this side, just this one. Okay, so we're left. So when we take a 2 out of 2u, when we divide 2u by 2,
just 1u.
We're just left with u. And then when we divide 2 by 2, we're left with
1.
1. Okay. So now we use this to form our factors. So the parentheses already give us a factor, right? So they are the exact same. So that's a shared factor. So that already gives us one of our factors. How do we get our other factor?
It's the 3u and the 2.
Yes. So we just combine them together and we do 3u plus 2. Okay. And we can check this by doing the multiplication. We can do 3u plus 2 times u plus 1. So 1 times 2 is 2. 1 times 3u is 3u. U times 2 is 2u. And u times 3u is 3u squared. Then we add them together. We have 3u squared plus 3 plus 2 is 5. 5u plus 2. So that is our original up here. So those are our factors. So 3u plus 2 and u plus 1 are our factors.
Okay.
All right, you still feel pretty confident about those?
Yeah, that's easy.
Okay. All right, so we're going to move on, and we're going to do the difference of squares. So this is very similar in the fact that it's the same concept, essentially. What happens, though, is when you do your AC method and you find your factors, you find the factors, and then your middle cancels out. So where your x would be is going to cancel out. So we're going to look at it visually first, this way with the algebra tiles, and then we're going to talk about what it looks like. So
is this lesson 25 still?
It is lesson 25.
Okay.
So this example is x squared minus 9. So we know that x squared is a square, and we know that 9 is a square. So what can we do with 9 to make it look like this? We have x squared, and then we can do something with this 9 to make it with an exponent squared. So what number would I square to get 9?
3 to the second power.
Yes, so 3. Okay, so it's really x squared minus 3 squared. So what that does is it tells us, by rewriting it that way, it tells us that we can use 3x because 3 times 3 is 9. So we can use we want a negative 9. So we can use a positive 3x, and we can use a negative 3x. And that'll give us 9. So our 3's will give us 9. And these are going to cancel out the middles. So what that looks like is if you were going to, I'm going to move this down so that you can see it. So if you were going to do this with algebra tiles, what it would look like is we have our x squared here, okay? And then we have our 9, negative 9. So they're gray because they're negative. So how do we have to build around this to make this negative 9 fit? So we need to build something around here so that it fits. And we want to do that by not changing the equation any. So what we do is we can add a negative and a positive, and that equals 0, right?
Mm-hmm.
So if I add a negative down here, I can also add, oops, I don't want to switch that one. I can also add a positive on top. Okay, and it doesn't change anything because these two cancel each other out. A negative plus a positive, negative 1 plus positive 1 equals 0. So I still have x squared, and then I still have my minus 9. So I want to keep doing that. So I can add another one here. I can add another one here. So 2x minus 2x is still 0. So I'm still not adding anything to my equation. Okay. I can add another one so that this fills up because I want to make a square is what I'm trying to do. So now I have 3x minus 3x, and that's still equals 0. And then I have my 9 over here, my negative 9 over here, and I have my x squared. So when I do my factors, when I write them out, I have x plus 3. Okay. Here's the positive 3. So this would be x plus 3. And then I have my x, and then I have negative 3. So those are my two factors.
Okay.
Okay. So there is I'm going to show you the formula to this here in a second. So there is a formula to this that helps when you have the difference of squares. So the difference is subtraction, and then both of those can be written as squares. X squared is x squared, and then 9 is 3 squared. So when you have the difference of squares, there is a formula. So we're going to do another example, and then I will tell you what the formula is, and it'll make it a lot easier. Okay. So this one, we have x squared minus 4. Okay, so how can I write the 4 to make it a number squared? So what number do we square to get to 4?
2.
Yes, so we square 2 to get to 4. Okay, so this is helping us. This is telling us our factors. This is telling us how many x's we need, positive and negative, to get to negative 4. So let's look at our square. So we're gonna build our square. Okay, so we have our x squared and we have our negative 4. They're gray because they're negative. Okay, so what can I do to build this square around it and not change this value any?
Add 2 of those 10 blocks underneath, on top and on the bottom of the square.
Okay, so if I just add all the gray ones and I have negatives, does that work?
Not, well,
Because that would be, so this is x minus 2, but I don't want to change the value any. So to offset the negative 2, I want to make that middle term
positive.
0. Yeah, so I have to add 2 positive. 2 positive ones, because I want that term in the middle to be 0. Because really what this says is it can be x squared minus 0x minus 4. Or plus 0x, I guess it doesn't matter. Minus 4.
Mhm.
Okay, so I want to keep this term 0. So in order to do that, when I add negatives, I have to add positives, or when I add positives, I have to add negatives to create the square. Okay, so
Yeah,
this, yeah, so this side gives me x plus 2, and this side gives me x minus 2. Okay, so
Mhm.
have you looked at the pattern? Have you
Odin.
identified it yet?
Yeah.
So
have.
so we have, on this one, we have x plus 3, x minus 3. And we can
Yeah.
rewrite this as x squared minus 3 squared. Okay.
Uh-huh.
On this one, we have x plus 2, x minus 2. And when we rewrite it, it's x squared minus 2 squared. So what do you think? What's the pattern? What do you think it is? Like the...
Is this like half of the AC method?
No, you could do the whole AC method and it would work. So what it is, when you have a difference of squares, so when this number is a square and this number is a perfect square, they're both perfect squares, we can rewrite it as, so when you have x squared plus a squared, okay, both of these are perfect squares, we can rewrite that as, I don't want plus, I'm sorry. I said the wrong thing. X squared minus a squared. We can rewrite this as x plus a, and then x minus a. And that's our formula.
We're just breaking it up.
We're just breaking this square up into these two factors. So if I go back to the x squared plus 4, or x squared minus 4, and I have x squared, or x plus 2, x minus 2. So when I break 4 and down to make it a square, like where it says a number squared, so 2 squared, I use this factor, and I can do plus that and minus that, and it's going to give me my factors for my perfect square. So when I factor these, I'm just going to do it by the FOIL method, okay? So x times x is x squared. X times negative 2 is negative 2x. Okay. 2 times x is positive 2x, and then 2 times negative 2 is negative 4. Okay, so these two will cancel each other out, and we're left with x squared minus 4.
Okay. Yeah, I remember that.
Okay, so if I do x squared minus 16, okay, 16 is a perfect square. How would I rewrite this in factor, like in a factored form?
X squared and 4 squared.
Yep, so I could rewrite it as x squared minus 4 squared. So that gives me my factors, right? When I break that down like this gives me my factors, or this right here does.
Mm-hmm.
So what am I going to write in my parentheses with my x when I write my factors?
X plus 4 and x plus 2.
Not x plus 4 and x plus 2. I would have x plus 4 and then x minus 4. Because we use the same factor because it's 4 times 4. So 4 times 4, because we have to have our last number to be 16, negative 16. Let's do it this way. Let me do this. I want to show you with the AC method. Okay. It'll work, I promise. So we don't have a b, except for we do have a b. Okay, it's just not there. So this is actually x squared plus 0x minus 16. Okay, so our two factors, we want to multiply together to get 16. And we want those two factors also to add together. Oh, we want it to be negative 16. I'm going to rewrite that so it's not so crazy looking. We also want them to add together to get 0. So what two factors of 16 can we add together to get 0? And it has to be negative 16. So we know these two factors because we broke 16 up and we made it 4 squared. Okay, so we know that our two factors are 4 and 4, but we want negative 16. So one of these has to be negative. Yes, so one has to be negative. Yep. It doesn't matter which one because you were doing multiplication and addition. So the commutative, it doesn't matter which order it goes in. So negative 4 times 4 is negative 16. Negative 4 plus 4 is 0. Okay. And since our coefficient right here is
non-existent.
1, well, it's there. It's just 1. Then we can just take these two numbers and write them as our factors. So we can do x minus 4 times x plus 4. And you can do those in any order. So I know I showed you this is x plus a, x minus a. It doesn't matter what order you do it in because it's multiplication. So this is a factor that we're multiplying against this factor. They can flip-flop because multiplication is commutative.
Yeah, okay.
So does that make more sense when you see it as the AC method?
Yes, it does.
Okay.
Honestly, yeah, I'm doing
so
that.
when our two numbers are perfect squares, so x squared and 16 are perfect squares, we are just going to take the factor that makes 16 that we have to multiply times itself that makes it a perfect square. So 4 squared. So we take this factor 4 and we do x minus that factor and then x plus that factor. And that'll give us our two factors. So we don't have to do the whole AC method. If you feel comfortable doing it that way, you're more than welcome to. It just takes more time. This is kind of like a shortcut because it works out every time when you have perfect squares.
Okay.
But you are more than welcome if you want to continue to do the AC method and to figure it out because it makes more sense to you. It's perfect. You can do that.
Will it work out every time though?
When it's perfect squares, yes. So if you have the difference, so a subtraction problem between perfect squares, it will work out. So perfect squares are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So if you continue that pattern, these are all perfect squares, and then anything times itself is a perfect square. If this factor here is a perfect square as well as this, it will work out this way. If you don't want to figure that out, I mean, that's something we should know as perfect squares, especially the first couple, I mean, the first 10. If you don't want to deal with that because you like this method because it is sure and it makes sense to you, use this method. This is just another method you could use. I think in your homework, it wants you to use the difference of squares. Like I said, it's the same thing. You're going to get the same answer. This one just takes a little longer. That's it. So if you can see the pattern and you can figure out this part, then it'll be really quick. If you don't want to do that and you feel more confident with the AC method, do the AC method.
Got it.
Okay. All right. So this next thing that we're going to look at kind of lends itself to the AC method, not the AC method, the difference of squares. You'll see what I mean when we get to the end. So this is in there. I had actually never heard of this before. I was never taught this, but it's interesting. So this is called Oriental squares. It works when when the two numbers that you're squaring, so if you have 15 squared, when the last number is 5 and the first number is the same. So, or when the last number adds up to 10. So 5 plus 5 is 10. And then our first two numbers are the same. So 1 and 1, those are the same. Okay. What you do, it's kind of an easy way to figure this out instead of taking 15 times 15 and then doing all the math. Like if you didn't have a calculator, it just makes it a little bit easier to do this. So right here, I built 15 times 15. So this is X. Oh, so this is 15. So 10, 11, 12, 13, 14, 15, 10, 11, 12, 13, 14, 15. Okay. And then we have, to make the perfect square, because it's a square, we have our 5 times 5 over here. So what you can do, theoretically, is you can take this, rotate it, and you can move it up here. And then you have 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then you have 10 and you have 10. Okay, so that's 20, right?
Mm-hmm.
So we have 20 times 10, because we're doing the area here. 20 times 10, which is what? What's 20 times 10?
Oh my gosh. 120. Wait, no. 200.
That's
200. Sorry.
200, yeah.
My brain just gave out on me.
Yeah, so we have 200, and then we also have this 5 times 5 left over that we need to do. So 5 times 5 is
25.
25. So your answer to this, 15 times 15, is when we move things around. So as long as you have the same amount of objects, you can move them around in these type of problems. So we have 20 times 10, so 200 plus 25. So our answer is 225.
Mm-hmm.
So what we did is we took 5 from one set here and moved it to the next one. So we did 10 times 20, but then we're left with the square, that corner square here, the 5 times 5. And that gives us 225. So I don't know what this looks like. So what I do is I take this and add it here. Okay. So then I have 20 times 10. And so that gives us our tens places. So it'd be 20 times 10. So that's 200. But then we still have this 5 times 5 to deal with. So that's 25 is what you're doing.
Mm-hmm.
Let's look at another example. Okay, so 25 times 25. So we have 25. So 10, 20, 1, 2, 3, 4, 5, 10, 20, 1, 2, 3, 4, 5. And then we have this block of 25 to make it a square. So what we can do is we can move these, whoops, up here. I'll make it a little better. Or you could move those down, either way. So we're going to make this square just a little bit different. So now we have 20, 10, 20, times 10, 20, 30. So we took 5 from 120 and gave it to the 25 and made it 30. So 30 times 20 is 600. And then we still have this block over here, this 5 times 5 block that we have to deal with. Our ones. These are our ones. And that's our answer. So instead of 25 times 25, we take 5 from one and give it to the other. And so that's 20 times 30. And then we still have to deal with our ones place when we do our multiplication. So then we have 25.
Yeah.
It's a trick. I like the visualization of it. I would rather multiply it out.
Yes.
if you ask me. Okay, so, and that's fine. So we're going to do this without the visualization. Okay, so we're going to do 45 times 45. So what we're going to do is we always have to deal with our ones place. So 5 times 5 is 25. So we're going to have that 25. Okay. And then what we're going to do is we're going to change this. We're going to make it 40 times 50. So our base number is 40. And then we're going to do it times 10 more. So times 50. So 40 times 50 is 4 times 5 is 20. And then you add 2 zeros. So 2000 plus 25. And that will give you your answer. So if you multiply this out, 45 times 45, it will do the same thing. So it's like, it's a shortcut, but it only works when your last two numbers equal 10 and your first two numbers are the same.
Let me write that.
I'm going to show you with another problem too, how that works. One that doesn't end in fives.
Mm-hmm. Okay, ready.
Okay, so if we look at this problem, 27 times 23. Okay, so our last two numbers are 7 and 3. Our ones place is 7 and 3, so that equals 10, right? 7 plus 3 is 10. And then our tens place are the same numbers, 2 and 2. So this will work because of that.
Yeah.
How it works is we can look at this in terms of like the blocks that we looked at before. So we were looking at blocks that ended in 5, right? So if we look at this in terms of 25, so I'm going to rewrite this like this, 27 times 23. I'm just rewriting it vertically. That's it. So if we think of this in terms of 25, we rewrite these in terms of 25. So if I take 27, and if I want to think of it in terms of 25, I can think of it as 25 plus 2, right? So 27 is 25 plus 2, okay? So if I look at 23 and I think of it in terms of 25, I can do 25 minus 2. That's 23.
Oh, okay. It loops back around.
Yeah, it does. So what we can do is now we can look at this as the difference of squares. So this is looping back around. So this is a square. And so like when I multiply these together, so if I would write it out like 25 plus 2, 25 minus 2, this looks like our difference of squares equation. So our difference of squares equation is a squared minus b squared equals a plus b times a minus b. Okay, that's our difference of squares equation. Okay, so I have 25 and 25. Those are perfect square, right? And then I have, so I can do 25. I have 25 plus a number and then 25 minus a number. So I can rewrite these as 25 squared minus 4 squared. Not 4 squared, I'm sorry, 2 squared. Okay. Because I have this part right here. So 25 is my A, 2 is my B. So then I can rewrite it as A squared, so 25 squared, minus B squared, which is 2 squared. Okay. And this will give me, that's a difference of squares. So 25 squared we know from back here is 625. Okay. So that gives me 625 minus 2 squared, which is 4. So my answer is 625 minus 4, which is 621. Okay.
Wow.
That is the answer to 27 times 23, 621. Okay. This is just showing you a relationship. It doesn't mean you have to do it this way.
Yeah,
It's
I'll never
showing
this.
you a relationship to the difference of squares and the multiplication of these numbers that where the ones equal 10 and the tens are the same. Okay. It's just showing you the relationship between them. Okay.
So this is why people take forever to check out at the grocery store. This is going through their head.
Then maybe. I mean, if they're good at math. So, okay. So the reason why you would need to know this is if you are manipulating a problem, we've talked about this before, and you are trying to factor things and graph things and do all that stuff, you can manipulate this in a way so that it creates like factors and you can cancel them out. So that's kind of what this helps you do. So when we get up into like quadratics and things like that, there's a chance that this could help you, or knowing this relationship could help you. You don't have to use it like this. You don't have to, like, if you have a number and you have like 36 times 34, you can just do 36 times 34. You don't have to do it this way in relationship to 35 and then find your difference of squares. Some people's brains work like that. We show you different ways to do math because there are different ways to do math. And sometimes it works better. Like your brain will pick up on something and say, oh, that visualization works for me and I need to use that. Otherwise, I don't know what I'm doing. And that's fine because people's brains work in different ways. So the more ways you are shown to do something, or the more ways you are shown how things are related, the better you're going to understand it as a whole. Does that make sense?
Yeah. Yes, it does.
Okay. So with that, let's do, let's work on your 25A.
Okay.
And then if you have questions, we can obviously get to those. So the majority of 25A is going to be the difference of squares.
Okay.
So it's what we did before this mumbo jumbo right here. What that looks like mumbo jumbo, but it is related. So I'm just going to do this. And this here. Okay. So on 25A, number 1 is you're factoring this, you're finding the difference of squares, right? Are you factoring it and then checking it? Is that what it says?
Yes. Find the factors and check by multiplying.
Okay, so we have x squared minus 4, which we did together already, so it's not. That was one of our examples. So we have x squared minus 4. Which method do you want to use to figure this out?
The short one.
The short one. Okay, so we know that this is a square, perfect square. We know 4 is a perfect square. So how can we rewrite 4 to know what the factor is that we're going to use?
2 to the second power.
Yep, so we can write it as 2 squared. So we know that 2 is our factors that we're going to use, and we want a negative 4. So one has to be negative and one has to be positive when we multiply them together, right?
Yep. Mm-hmm.
So what are our two factors?
X minus 2 times x plus 2.
Yes. And then they want you to check by multiplying. So you can use either method. You can use the FOIL method or you can use the vertical method to check.
Mm-hmm.
It doesn't matter. You should just get x squared minus 4 when you're done.
Okay.
Okay,
Got
did
it.
you, okay. And it
Mhm.
checked out x squared minus 4?
Yep.
Great, okay. So number 2 is x squared minus 16. So you're going to do it the short way?
Definitely.
Okay. So how are you going to rewrite that so that you can see the factors?
X squared minus 4 squared.
Yes, x squared minus 4 squared. Okay. And then what are your two factors?
They're x minus 4 and x plus 4.
Okay. Good job. And then just multiply it to check.
This one checked out also.
Okay. Good job. All right. Number 3 is x squared minus 25.
X squared minus 5 squared.
Okay.
So did this one.
Okay. What were your two factors?
X negative 5, x plus 5.
There you go. Okay. So these are not terrible when you see the pattern, right?
Yeah.
Okay. Number 4 is y squared minus 144. So don't let the y fool you.
Of course not. Y squared minus 12 to the second power.
Yes. So y squared minus 12 squared. And what are your factors?
Y minus 12 times y plus 12.
Great.
Okay, this one's right.
Okay. So for number 5, we have x squared minus 100.
Which is actually x squared minus 50 to the second power.
Try that one again. 50 times 50 is not 100. 50 plus 50 is 100.
I caught it. Wait, hold on. This is incorrect. It's 10.
Yes, there you go. And then what are your two factors?
X minus 10 and x plus 10.
Great job.
This one checks out.
Great.
I think all of them check out.
Well, that's what we want. So if you would have kept 50 and you would have done x minus 50 and x plus 50, you would have figured out it wouldn't have checked out. So that's why we do that too, to check ourselves.
Oh, okay.
Yep. So number 6, x squared minus 81.
Oh, it's actually x squared minus 9 to the second.
Yep. So your two factors are,
X minus 9 times X plus 9.
right.
That checks out.
Okay. The next one is x squared minus 49.
That's X squared minus 7 squared.
Mm-hmm. So your two factors are,
X minus 7 times X plus 7.
great.
This one also checks out.
Great. That's what we want. All right, the next one is x squared minus 64.
I'll do it wrong just so it doesn't check out for once.
Don't do it wrong on purpose.
It's annoying how it keeps checking out. This one.
Well, that's actually good. We want it to check out though.
This one is X squared minus 8 squared.
Okay.
My factors are X minus 8 times X plus 8.
Great.
This one checks out also.
Good. All right, what the next one is a squared minus 121.
That's actually A squared minus 11 to the second power.
Yes.
And my factors are X minus 11 times X plus 11.
Great.
Okay, this one checked out.
Okay. So the next one is x squared minus y squared. What are you thinking?
A lot of things actually. So I think this is just X squared minus YX. It just stays like that.
So yeah, so they're both already written as those squares, right? They both already have the second power up there. So we don't have to rewrite it as anything. So it's x squared minus y squared. So what are our two factors going to be?
Just that. Oh wait.
We'll still have two factors. We'll still have to multiply.
X plus Y.
X minus y, yep, and then x plus y. Good job. And then you can still multiply to check this one.
Of course. All right.
Did it work?
Yeah, I think so. So I did x minus y times x plus y, and then I had yx, and then under that negative xy, and then beside that x squared.
Okay, so we have, when we do x minus y and x plus y, the first thing we do is y times negative y, which is negative y squared. Then we have yx.
Oh.
Don't forget that first factor, yeah. And then we have x times negative y, which is negative yx. And then x times x, which is x squared. And we add them all together, so we get x squared, y positive yx minus yx, those cancel each other out, and then we have negative y squared left.
All right.
Is that what it looked like at least?
A little bit, yeah.
Okay, but you understand that. I know it's different when there's not numbers.
Yes.
Yeah, okay. All right, the next one is, I think, b squared minus 4, which you've actually already done, just with a different letter.
Yeah. So b squared minus 2 to the second power.
Yep.
And that's b minus 2, b plus 2.
Yep.
This one checks out. I have b squared minus 4.
Great. So the next one is x squared minus 9.
That's x squared minus 3 to the second. X minus 3, x plus 3.
Yes. Oops. Now, look at what I just wrote. If we would check that one, would it work?
Nope. Because you
Nope.
have...
I have no clue why I wrote 4.
Don't worry, I do that all the time.
But sometimes we do that, right? Our brains make mistakes and we do that. And so when we go back and check it, like if I would write that out and check it, I would know that I was wrong somewhere because it wouldn't work out.
Yeah, I hate it when my brain does something opposite that my eyes do.
Yep. Sometimes my brain or my hand will work faster than my brain does.
Yeah. X squared minus 9.
Okay. All right, read me the instructions for the next one because I have the problem, but I don't know what it is actually.
There are instructions. It just skips from 12 to 13.
Okay, so, and then 13 is 65 times 65, right? So
Yes.
you can do this. What it's wanting you to do is that trick that we did.
No.
The Oriental squares. So in order to do that, so we have the 5 times 5, right? We always have to deal with our ones. So we have 25. So 5 times 5 is 25. Okay. And then we're going to take this and we're going to make it 60 times 70. So 60 times 70. And then in order to do that, I take 7 times 6, and that's 42. And then I add my 2 zeros at the end. And then add 25. And you should get your answer, 42.25. So if you do it the long way, like the normal multiplication way, you should get the same thing.
Yep. Wow. Okay.
Okay, so the next one is 48.
35.
Nope, 35 times 35. Sorry, I skipped it. It's stacked weird in this answer key. 35 times 35. So how do I do that? How could I do that? My short way. What would I take? 30 times what?
Yeah. Oh. 30 times 5?
30 times 40.
How does that happen?
So we take our ones and we multiply them together. Okay, so that's 25. 5 times 5 is 25.
5 or 10. Yeah, that makes sense now. Okay.
Yeah, and then we add the 10, we add the 5 up because we have to do our ones place. So now we're just dealing with our tens place. But those two, so we have to add them together because they add to get 10. So we do 30 times 40. So that's 1,200 plus 25. Does that make sense? The short way. I mean, you can do it the long way. I really don't care.
I like the short way.
It's easier. I mean, it's quicker when you understand it. Okay, so
Yeah.
the next one is 48 times 42. So this one we're going to have to do a little bit of finagling. Okay. Okay. So we can do this the exact same way. We can either look at it as difference of squares, or we can do it the exact same way. It's not that big a deal. So what we can do is take 8 times 2, which is 16. So we take our ones, multiply them together. But then we have to add, so we can do 40 times 50, because when we're multiplying our tens place, we have to account for that extra 1, that extra 10 from 8 plus 2. So that's 2,000 plus our 16 from multiplying our ones together. That's 2016.
Okay.
Yep. This one we could also look at as like difference of squares. So you could do 45 plus 3 and then 45 minus 3. So that would be like 45 squared minus 3 squared. So 45 squared is 2025 minus 9, which gives us 2016. So this one is a little bit more difficult, but it brings in what you were learning with the difference of squares. This is just as easy to do it this way on the left, where we take our ones, multiply them together, and then add the 10. Okay. What about the next one? You tell me what to do. So 85 times 85.
I take my ones, which is 25.
Okay.
And then I have my 10, which is 90. And then I have 7,200 plus 25 equals 7,225.
Yes.
Cool.
7,200 plus 25. So remember, that only works though when your ones place equals 10, when they add up to equal 10, and then your tens place is the exact same number.
Mm-hmm.
So it has to be the same number. Okay. So how do you feel about that? Good?
Yeah, it's fine.
Okay. But how do you feel about the difference of squares? This I'm not so much worried about. The difference of squares is really what?
That one I'd like to review.
The one we just did, where it's like b squared minus 4? Like the whole thing you just did.
I have the equation written out, so I can figure it out. I'm not terribly confident with that one, but I like the one we just did.
Okay. Okay. So when we meet Wednesday, we'll review this a little bit before we go on. Does that sound good?
Yes.
Okay. So with that, I don't know if I've told you this before, and I know I've shared these with you a little bit. So we do for Family Focused Tutors, the company that I work for, we are doing like a verse per month. So December's verse, since it's December 1st, I'll share it with you. So Psalm 27:1 says, the Lord is my light and my salvation, whom shall I fear? So the suggestion that they have is to write down something that you feel afraid of or a fear that you have on a piece of paper, and then put it in a box or do something with it. I mean, sometimes what I do is write down like something I'm afraid of, like if something's coming up, and I'll write it on a piece of paper and then I'll like rip it up. And then remember that God's in control, right? God is bigger than all of our fears. So we shouldn't fear anything when we know that God's got control of everything.
That's correct.
So if that's something like if you're, coming up this month, there's something that you're worried about or you're afraid of, I mean, do something like that. Write it down, rip the paper up, write it down. Well, if your parents will let you. We have a fireplace, so we could like throw it in the fire, or like don't use fire without your parents' permission. Or like, put it in a box and know that God is bigger than all of that. So
put one of those God is greater than your ups and downs stickers on the box.
Yeah, there you go. So all right, so is there anything else, anything you have questions about right now, anything I can pray for you about, anything at all?
Oh yes, my novel. I'm in the most stressful stage right now. It's editing. I still have to, it's a lot. So that please.
All
what
right.
about you? Is there I can pray for?
Just, you know what? My son has to go back to the doctor Thursday. And so hopefully he's got good healing and he can get his brace off and he can start doing some more exercises so he can get back to playing basketball. So.
Okay. Yeah. Got it.
Yeah. All right. So, I'll see you on Wednesday then. So I hope you have a good couple days and I'll see you Wednesday morning. Okay.
Yeah. I hope you have a good one day.
Oh yeah, I'm sure I will. So, all right. I'll see you later.
Toodles.
Bye.